Okay, in this problem, we're supposed to use Gauss's approach to find the sums of the following arithmetic sequences. Let's take a look at A. So we have 1 plus 2 plus 3 plus 4, and then dots, turns in the middle, 94, 96, 94, 95, 96, 97. Okay, so the first thing I want to do is find the common difference. Okay, so what is the common difference here? The common difference is the difference between each successive term. So 2 minus 1, what's the difference? 1. 3 minus 2, what's the difference? 1. So the common difference in this, every one of them has a difference of 1. Okay. The next thing we want to do is figure out the number of terms, and I'm going to do that by doing the last term minus the first term divided by the common difference plus 1. Okay. So this will be 97 minus 1 divided by 1 plus 1. Okay. So when I do that, I get 97 minus 1 is 96 divided by 1, still 96 plus 1. I get 97. Okay, so I have 97 terms in this particular sequence. Okay. Now to figure out what the actual sum is, here's how I'm going to do that. I'm going to say, well, we know the sum is what we already had, 1 plus 2 plus 3, I won't write all these terms, plus 95 plus 96, 96 plus 97. Okay. I'm also going to write it another way. I'm going to start with 97 plus 96 plus 95 plus plus 3 plus 2 plus 1. Now I'm going to pair these like the 95 and the 1, the 96 and the 2, the 95 and 3, the 3 and the 95, the 2 and the 96, and the 1 and the 97. Now if I pair those like this, I'll have two S's. So I'll add these straight down. I'll say I have 2 of the S's now. And I'll add each term together. So I'll have 1 plus 97. I'll have plus 2 plus 96. Plus, and keep the 3 plus 95. I want to write that because I'm running out of room. Plus 95 plus 3 plus 96 plus 2 plus 97 plus 1. Now, how many of these parentheses do we have in this? Well, there should be the same number of parentheses in this that there are terms in either one of these, right? Which we already figured out there's 97 terms, right? 97 terms in this. So if we paired them together like this, there's 97 parentheses, right? So each one of these parentheses adds up to 98. So how many 98s do we have total? Well, we have 97 of them. 97 terms. Okay, so 2s is equal to 98, because each one of these adds to 98, times 97, because there's 97 of the 98s. Okay, and then we can divide by 2. S is equal to 98 times 97, divide by 2, and that's going to give us 4,753. Okay, now let's take a look at the next problem. Okay, so the next problem we have is 1 plus 3 plus 5 plus ... and then 1001, 1003, 1005. Okay, so here we go. All right, so we're going to go through the same exact process that we just did. The first thing we did was find the common difference. D, common difference D. And the common difference is you just subtract two terms, like 1005 minus 1003, what is that? 2. Or 5 minus 3, what is that? 2. So the common difference there is 2. Now what about the number of terms? Remember, we did the last term minus the first term, divide by the common difference, and add 1. So the number of terms is equal to 1005 minus 1 divided by 2 plus 1. Okay, so that's 1004 divided by 2 plus 1. That's 502 plus 1, or 503. So 503 terms. Okay, so if there are 503 terms, now we're going to do exactly what we did last time by doing the two different S's. The sum is 1 plus 3 plus 5 plus ... Okay, there's that one. And then I'll write it backwards, 1005 plus 1003, 1001, dot, 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 5 plus 3 plus 1, so that I compare them and get two s's. Remember, we're adding down, and we're pairing these into parentheses, and each equals 1 plus 1005 plus 3 plus 1003 plus dot, 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 let's go all the way to the end, plus 1005 plus 1. Okay, so how many of these terms do we have, and how much is each one of them worth? Well, we know that each one of these adds up to get 1006. You can just look at each one of these and see that. Okay, so how many of these 1006s do we have? Well, we have 503 terms, so we have 503 parentheses. So what we have here is 503 of the 1006s. So 2s is equal to 503 of the 1006s. So we're multiplying those. Okay, so s is equal to 503 times 1006 divided by 2, and that will give us 253,009. Okay, that's the sum. All right, let's take a look at the last one. We have 4 plus 9 plus 14 plus dot, 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 plus 499 plus 504 plus 509. Okay, so if you remember, we find the common difference first. I'm going to skip some steps on this one since we did it twice already. The common difference is 5. You can just subtract any two terms, 5. Number of terms. Well, the number of terms are going to be 509 minus 4 divided by 5 plus 1. Okay, so that's going to be 505 divided by 5 plus 1. That is going to be 102. So we have 102 terms in this problem. Okay, now let's figure out what the sum is. Okay, so we have s is equal to 4 plus 9 plus 14, and you don't have to do this every time, but I'm doing it because I want everybody to make sure and understand this process. Plus 504 plus 509, and then we have another s is equal to 509 plus 504 plus 499 plus dot, 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 1494, which means 2s is going to be equal to, and we could add these together, just skip this little step right here. So it's going to be 4 and 509, which is what? 513. So that's worth 513. You add these together, that gives 513, another 513. So how many of these 513s do we have? Well, the same number, just like we did before, the same number as we have terms. So there are 102 of the 513. So 2s is equal to 102 times 513. S is equal to 102 times 513 divided by 2, which is going to give us a final answer of 26,163. And that's the sum.